Hey guys, I'm just going to take you through now another example of how to solve an algebraic equation. This was one of the practice questions from the slideshow. So again, we got two sides to an equation. We're trying to figure out what number this x represents. We don't know right now. It's an unknown. That's why it's represented as a variable or a letter. Negative 3x minus 8 equals 40. Okay, so remember, there's always two sides to an equation separated by the equal sign. I usually just do a light dotted line to remind myself that there's two different sides. This side already has a variable in it, so I'm going to call this the variable side of the equation. And the reason I do that is just to remind myself I want this x by itself on this side of the equal sign, and then over here I don't want any x's. Okay, and there aren't any, so we're in luck. So negative 3 times x minus 8 equals 40. This minus 8 is bugging me. I want this gone. Okay, it's just in the way. And the only way to get rid of a negative 8 or a minus 8 is to add 8. You always do the opposite operation. So if it's subtracting 8, I'm going to add 8. So my next step, I'm going to rewrite the equation. Negative 3x minus 8 plus 8 equals, okay, because now I've added 8 to this side of the equation, I have to do the same thing on this side. So I'm going to go 40 plus 8. All right, so now negative 8 plus 8, those are opposite integers, right? They cancel each other out, they become 0. Negative 8 plus 8 is 0. So I'm left with negative 3x on this side of the equation. And now, when I go to the other side, I just complete the addition. 40 plus 8 is 48. Okay? Makes sense? All right, now, here's the tricky part. I have to get rid of this negative 3 because I want the x all by itself. But again, negative 3 times x. These are attached together. I can't just add 3 to get rid of that like I did up here. They're attached by a multiplication. So the opposite of multiplication is division. I have to divide by negative 3 to get x by itself. So I'm going to put the division line here like a fraction, and I'm going to divide by negative 3. And then I have to do the same thing on the other side. Always make sure you remember to do the same thing on both sides of the equation. That's the only way to make it equal. All right? So if I do negative 3x divided by negative 3, the negative 3's will cancel each other out, and I'm left with x all by itself. That's beautiful. That's what I want to see. It equals 48 divided by negative 3. Well, that should be, just by straight up arithmetic, negative 16. So I'm saying, according to my calculations, x equals negative 16. So how can I prove that that is in fact correct? The only way to do that is to put my answer back into the original equation. So I'm going to rewrite it out again. Negative 3x minus 8 equals 40. All right? So I'm going to replace this x now with negative 16. So it becomes negative 3 times negative 16 minus 8 equals 40. All right, so I haven't done any calculations yet. I've just substituted my answer from here into the original equation. I've replaced that x with the negative 16. Negative 3 times negative 16 should be 48, right? But I have a negative times a negative. It's going to be a positive answer. So it's going to be 48 minus 8 equals 40. And remember, you always want the two sides of the equal signs to be equal. So if I do 48 minus 8, I'm left with 40, which equals 40. And then I know for sure I am correct, okay? Because my check worked out. All right, so this is how you do your check. Okay, looks good. I might try another example after this.